go ahead and get started. Let's introduce our speaker for today, Dr. Tim Oates. Tim is the co-founder and chief data scientist at Synaptiq, with over 20 years of experience in guiding organizations and companies of all sizes, applying AI and machine learning to business problems across industry. Dr. Oates earned his PhD in computer science from University of Massachusetts Amherst, with a focus in AI and machine learning, and was a postdoctoral fellow at the MIT AI Lab. So thank you, Tim, for speaking with us today. I will go ahead and let you take it from here.
Okay, thanks, Sam. I appreciate it. So just real quick, I want to spend 60 seconds talking about Synaptiq. So we're a AI machine learning consulting company. We've been around about 8 or 9 years. As you saw in the previous slide, we've had more than 100 clients. I think that number is actually an underestimate at this point. We, in the early days, just did a lot of projects where we would work with companies who said, hey, we believe that AI or machine learning could help us solve a business problem. We'd go in and consult on that. Turns out our team actually has pretty broad expertise among the co-founders and the people that work with us in product, user experience, data engineering. So we tend to think of ourselves these days more of an intelligent products company. So the idea is that we go sort of from beginning to end. That is, what's the idea for the way in which data, AI, machine learning can help your organization all the way to deploying products that users are going to interact with, whether those are internal or external. So the outline today is pretty straightforward. I'm going to start out talking about what are artificial intelligence and machine learning and data science. Just, a couple of slides on that. It'll be useful when we start talking about some of the construction applications. And I've got a list of them here. We'll talk about predictive maintenance, improving bids and estimates, tagging data for better retrieval, evaluating and training people, and writing proposals faster. Along the way, we'll see that using large language models like ChatGPT are really, really helpful in some of these, in particular, the ones that have to do with text. So tagging data, writing proposals. And so I'll spend just a few minutes kind of talking about what large language models are. Maybe you already know that and you're really familiar with it, but it's a good background to have if you haven't really sort of looked under the hood a little bit. As Sam said, I'm also super happy to answer questions. I get tired of hearing my own voice. So if somebody has a question and you want me to answer it, as I'm going along, drop it into the chat and Sam will potentially interrupt me, or maybe she'll save it for the end. So, okay, so that's sort of where we're going. And as I said, we'll start out kind of sorting out some terms. If you think about sort of machine learning and AI, and you hear a lot about deep learning, back in the early 90s, when I started on my PhD, there was sort of artificial intelligence, and AI was concerned with all aspects of human intelligence. So things like learning, which is very common these days, but also natural language processing, sort of how do we communicate using human languages, and planning, game playing, sort of all the things that we do, that people do, that we think of as being intelligent. A part of that is machine learning. So, in machine learning, it's the study of computer programs that get better at something with more data. And then within machine learning, there was this notion of deep learning, which were neural networks, which have been around for a very, very long time. But these are neural networks that have lots and lots and lots of neurons sort of arranged in layers. And so, interestingly, what happened to the field is machine learning kind of ate AI. So these days, when they say, I do artificial intelligence, they usually mean we're doing machine learning. And then deep learning ate machine learning. So when somebody says they're doing machine learning, they typically mean deep learning. So, this sort of notion of these neural networks doing all the work for us has kind of shown itself to be remarkably powerful. And, in the press, when you hear about AI, they really mean machine learning. And when you hear about machine learning, they really mean deep learning. So aligned with that are statistics. There's a lot of utility in just sort of understanding data distributions, data engineering, sort of moving data at scale from one location to another, getting it ready to be ingested by these algorithms, and also, sort of business intelligence. There is no substitute for the human visual system when it comes to sort of looking at data and making decisions on it. So Briefly, I just wanted to talk about different kinds of learning. There are three kinds that I'm going to talk about. There's supervised learning, which is I've got things and they're labeled by type. So in this case, I've got emails and I can label them as important, and then there's everything else. And I think, like Gmail allows you to do that kind of thing. So the idea is I can say, is this email message important or not? Um, I have a request for proposals, and I would like to know, will my competitor bid on it? I might have audio from an HVA system, and I want to know whether the compressor is bad or not, or employee data, and is this person likely to quit in the next 6 months? So in all these cases, you've got a data set where you've got things, and then you've got historical data that tells you what the label is for that thing. And supervised learning says, okay, what I'd like to do is use that data to build what we call a model that will take a new thing and then make the prediction, right? Oh, here's a new RFP. Is my competitor going to bid on that thing or not? Unsupervised learning is similar, except you just get things and you don't get labels. So maybe I give you a bunch of email messages and you want to figure out what are the distinct topics. Or I've got customers and their order history, and I want to figure out, are there groups that have similar buying habits so that I can do better at marketing? Or I've got vibration data from an escalator in a shopping mall, and I'm just trying to figure out, is it vibrating in a weird way? Because maybe that means that it needs to have maintenance applied to it. And then the last one is reinforcement learning, which is, people have heard about a little bit less if you're not in the community, but unbelievably powerful method that's getting a lot of play these days. And so in this case, you're a system, you're able to take actions and get feedback from those actions, and you try and get better at some task. And so reinforcement learning systems have actually have been used to construct world-class Go players. There's a movie about AlphaGo. You've probably heard about that in the press. Reinforcement learning systems can learn to play Super Mario Brothers unbelievably well and have been used in autonomous driving, for example. So I've got to take actions in the world, and I want to take actions that are good ones to take. So given that quick background, what I'd like to do is just talk about some applications of machine learning and AI in construction. And these domains are a little bit broader than construction. That's okay, but I think the applications in construction are going to be pretty obvious. So one is predictive maintenance. So in predictive maintenance, I've got something. I've got a compressor or some machine of some kind that I'm using to get work done. And in general, maybe you do sort of routine maintenance on it or preventative maintenance. But what happens is eventually those things are going to fail. And so on the left-hand side, I've got my machine. It seems like it's working well. On the right-hand side, you crank it up and somebody goes, I don't know, man, that doesn't smell right. Or it's making this weird noise. And then eventually, if that starts becoming pronounced enough, the thing just breaks down. So at that point, you got to fix it. What we'd like to do is to be a bit more predictive about it. So it's pretty common these days to, for example, attach vibration sensors or ultrasound, or look at the pattern of power that's being consumed, right? Or to use infrared. So infrared, for example, is often used to look at concrete to see if there are cracks in it that are evolving. So in predictive maintenance, the idea is, can I put some sensors on a piece of equipment and gather data and learn from when the machine breaks down and doesn't break down what the early indications of that things are, right? So then I can fix it and I have less downtime. So here's a very concrete example, a project that I worked on a long time ago where we had a data acquisition sensor that had 653 binary sensors that were measured every 1 millisecond. And it doesn't matter, they were just sort of a switch. You try and sort of change the state of a switch. And good behavior is when you get this nice clean transition where it goes from open to closed or closed to open. And it turns out that the human experts said, well, you know what happens when that thing is getting ready to fail is it kind of chatters a little bit, right? It's like it tries to close and then boom, it finally changes state. So a supervised machine learning approach there could be pretty straightforward. You go, okay, look, I'm gathering data from these sensors that are measuring these physical switches, and I can label them as good or bad, right? So the top three, that's good behavior. The bottom three, that's bad behavior. We want to be able to figure out when it's going to go in that direction. And what you do is you hand that data to a machine learning algorithm, and it says, all right, given that data, I'm going to learn to make predictions. And so I take a new thing in where this is actually data that I'm gathering in the wild, and it says, yep, that thing looks like it's good. So that's the supervised learning approach. Another approach could be just an unsupervised anomaly detection. So I've got a whole bunch of data up here that was gathered when everything's running smoothly and there weren't breakdowns in the near future. And what I want to do then is to, in an unsupervised way, just go, well, here's this new thing I observed. Is it similar to normal operating behavior? And if it is, I'll say everything's okay. And if it's not, then maybe I need to have a human take a look at it, right? So some considerations are, if you want to think about applying machine learning to your particular problem, the way I tend to think about a lot of these things these days is is could a smart person who's worked with that equipment for 40 years, and that's a long time, right? But do you have somebody that's been on staff 10, 15, 20 years, and they're really good at going, yeah, I think that thing's about to break. Then I think a machine could probably do it. It might even be the case that a machine can do it if that person doesn't exist or they have a hard time predicting it. But if there's an expert around who can handle that task, then usually a machine learning system can do it. And then you got to look at what information would that person use or need, right? So can I sense that, right? If the only way they do it is they go, it kind of smells burnt, that's harder to get than if they say, oh, like it's making this weird sound, right? Sound is easier to measure. Then you got to think about what's the return on investment. So what's the cost of downtime? How painful is that? But you have to balance that against the cost of the instrumentation and the data storage. So is it an exotic sensor? Is it going to generate tons of data and I've got to pay to store that and transfer it? And then what's the expected increase in uptime? So, if you look at that and think, well, it's really expensive when this thing breaks, and my expert goes, I just kind of listen to it. And so it's easy to put an audio sensor in there, not a lot of data, then it's sort of a no-brainer. And then you have to think about what's the approach. Is it anomaly detection? Is it supervised learning? Or is it the case that you could just visualize the data and show it to somebody and they go, yep, that thing's going to break? Okay. So another problem that happens in a lot of industries, construction in particular, and this is one that we've worked on inside the company at Synaptiq, is improving bids and estimates. So, what you have to think about, what's the problem I'm solving and where's the data? So what you'd like to do is to win a job and not leave money on the table. And so we worked with a client once who wanted to solve two problems. One is, will my competitors bid on this thing given a request for proposals? And then what is the amount that they're going to bid? So, let's imagine that you could do that perfectly, which you can't, but let's imagine for the moment that you could. Then you would simply go, okay, here's an RFP. Let me figure out which of my competitors are going to bid on that thing. How much are they going to bid? And then what I do is I just underbid them by a little bit, right? And you can treat this as a supervised learning task. So, what we looked at in that case was internal documents. So, what are emails about bid creation from the past? Look at postmortems on bids and projects. Are there guidelines that you have internally, for example, about the processes and knowledge, right? That can be encoded as text. There's public data like the calls for proposals, job location information. So, for example, especially in construction, if I need a lot of concrete and the job is very far away from all the places that I can, obtain concrete, then it's going to be way more expensive for me. And then historical information about competitors' bids. And then you've got internal spreadsheets and lots of different kinds of data, right? So the idea is that you might have lots of different kinds of data. The general approach here is talk to experts. Again, it kind of comes back to human experts. What information do they use and how do they use it? That's very valuable. And then what are their rules of thumb? So once you've sort of sorted that out, you can get the relevant raw data, like from that first item, into one location, like a data lake. Often there's a sort of a cleaning process that goes on because you got lots of different formats and different qualities, and then potentially enriching it as needed from external sources. And then build predictive models. And importantly, again, sort of at all stages of this, it's super important to use your internal experts to inform how the model is designed in conjunction with people who are in the business of building predictive models. And so you can train it with a supervised method to predict bidders and bids, typically with uncertainty measures, right? So there's a very big difference between saying, I know for sure that, my competitor across town is going to bid on it versus, I don't know, there's a 20% chance that they're going to bid. And then you have to test very carefully. So the company that we worked with in the past, there's no way they would just take this machine learning system and go, oh, okay, yeah, like these two guys are going to bid. They're going to bid 2.5 million and 2.7 million, so we're going to come in at 2.4 million. They used it as an additional piece of very useful information in their overall processes. Now, another thing that happens is often you've got data lying around and you've got keyword search, for example, or various sort of methods for typing in keywords and retrieving information. And if you can do that better, then your internal processes or external processes can be improved. So the idea would be mapping from text to tags or keywords. And again, can a human expert do it? If there's, or even just sort of, a person off the street, if you could say, hey, I need to tell the difference between passports and driver's licenses. Can you do that? And if a human goes, yep, I can do it, and do it pretty accurately, then it's probably the case that a large language model like ChatGPT or any of the many ones that are available can do it too. And so the idea is it allows you to do better document search and retrieval. Here are a few different examples. We worked with a legal firm, and I know this isn't legal, but we worked with a legal firm that was getting lots of documents. They were getting scans of driver's license, covers letters, government forms, but every office has lots of different kinds of documents floating around. And they needed to be able to take a PDF and label it as to what kind of document it is. Um, you could look at requests for proposals to job types. We'll see an example of this a little bit later, actually. So, is it new commercial construction? Is it renovation? Is it a design problem? And what that can help you do is just sort of say, oh, we're into commercial construction. Let's, search a database to see which ones are available. Or you can just extract information. So I'm doing inspection reports and I want to find the name of the inspector, the date, and the issues found, right? So another use case. Now, let me just take we've got time, I think. So I'd like to just dive for a couple of minutes into large language models. So LLMs, large language models. Just give me 3 minutes and we'll kind of get through it. Um, what are they doing? And I think that's helpful in trying to understand the use cases to which they apply and how you interact with them. So, what's a language model? A language model is just an old term that says, hey, given a part of a sentence, predict the next word, right? So, if I start a sentence, the cat, and I say, can you please tell me what word comes next? There are lots of words. Sat, that seems like a feasible word. The cat slept. Cats are sleeping a lot. That seems like a feasible word. Filibustered, I don't know, like, no, I've never heard that sentence before, except that I wrote it, right? But I've never heard that sentence before. Probably not. Or the cat cactus, right? Like, just those don't make sense. So, what language models do, though, is they're slightly more subtle than that. They don't go yes, no, but they say, hey, 10% chance that the cat's going to be followed by sat, 8% chance it'll be followed by slept. I don't know, like filibuster's not impossible. There could be a children's book where, cats are members of Congress and they're filibustering. And the cat cactus is weird, but I don't know, we won't rule it out entirely. So, um, here's an example. I actually got a bunch of recipes from the web, ingredients and instructions. And so what you can do is you just write a little bit of code and you can say, well, conditioned on the previous words or the previous two words, let's generate the next word. So a language model would do something like, oh, you want to start an ingredient. Let's see what's the thing that follows start of ingredient, right? It's like one. I need one of these things, or one and a half, or two. But now that I've got start ingredient one, it's typically going to be a unit of measure, like a teaspoon, for example. So now that I've got a teaspoon, it's going to be a teaspoon of something. Well, it's going to be chili. And what tends to follow chili in recipe ingredients is powder. And then after powder, oh, okay, it looks like we're done, right? So that's all a language model does, is it understands what's the probability or what are the chances that all the words I know, they're going to come next given some context, right? So you can get things like 1 cup salsa, 1/4 teaspoon black pepper. Now, the interesting thing is that if you just condition on the previous word, you can get weird stuff like 1 pint and then 8 ounces. um, softened, right? And so the idea here is that that seems like we've sort of lost track. There's probably lots of ingredients like softened cream cheese or cream cheese softened or butter softened, right? And so it sort of lost its mind. And you can see that you can get really weird stuff like 1/2 cup applesauce or more for frying chicken stock low sodium, right? And so you can sort of look at this and go, ah, well, given one word, the next one that comes seems like it's okay, but it just sort of goes off the deep end. So the thing about large language models is it's just web scale data. Um, Hundreds of billions of numbers sort of represent that distribution over next words. My little recipe model used 10 million numbers. Then the real trick, the thing that was the real innovation, is that a few years ago, in a very famous paper entitled Attention is All You Need, some people figured out how to condition the next word on the entire sentence, right? So I can look at a bunch of stuff that's been said before and then go, oh, okay, here's what I think the next word is going to be. And so, like those two things, tons of data, and then this very clever way of being able to say, given everything you've said to me so far, what should I say next was the power. And then finally, you've heard this term prompt engineering, where a prompt is just something you say to a language model. I say, hey, LLM, can you help me do something with this bid? And it goes, yep, I can do that. And so the turns out that LLMs are really sensitive to how you phrase what you say, even within a single language model, but also if you're playing with different ones. Because what they do is they just sort of think, left or right, like next word, next word, next word, next word, right? So um, and then prompt engineering is just how do you get LLMs to give you the answer that you want in the right format. So let's look at a couple of examples of this. So here, what I did was I took a tax form, and it turns out that you can do this on Chat GPT and other language models. So I don't know if you've used Chat GPT. There's a little paperclip icon. We'll see a picture of it in a minute. But with a paperclip icon, you can click on that and upload a document, and then you can start talking to Chat GPT about the contents of that document. So I found a random tax form. I downloaded it to my machine. I uploaded it to Chat GPT, and I said, "Hey, what IRS tax form is this?" And it gives me this like very detailed answer. Oh, it's IRS form 990 for the year 2023. It's used by certain kinds of organizations under certain sections of the IRS code, blah, 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 right? So that's great. That's helpful in some cases. Um, but what I might want to do is do something that's more of an information extraction problem. So you've got some documents in your company. You just want like, which is this thing? I don't need all the extra stuff. So I say, what IRS tax form is this? Just give the form number. And it goes form 990, which is getting closer, but I really don't want form on there. So I changed my prompt and I said, what IRS tax form is this? Respond with just one token. And token is just language model speak for sort of a word, which should be the form number. And actually, I misspelled number. I wrote it numner. But it's smart enough to know what I meant, which again is remarkable. And it goes 990, right? So now the interesting thing about this is it's just highlighting the need for kind of iterating and thinking about how you're talking to language models to get information out of them. But it's not hard, right? They're pretty forgiving and they don't get tired of you asking them questions. Here is another example. So this is the tagging example that we were thinking about earlier. So um, I got a home inspection report, and I just found one of these things on the internet. And I'm thinking, okay, what I really want to know is sort of what kind of problems were discovered in this inspection report, because it might be super useful to identify things like, oh, this geographic region seems to have a lot of problems with water damage. So in this case, I said, does this report mention problems with water damage? And it gives me like a really good answer. So it says, yes, this report mentions potential water damage concerns. So there's the window wells do not have water resistant covers. There's a basement sump pump. There is no high water level alarm in the sump pit, though there's no sump pump there. And there's erosion of soil underneath the patio concrete, which could lead to water related issues, right? So, and again, notice I just uploaded a PDF. And so what the system did was it looked at that PDF, extracted what it needed to be able to respond in this way. So I said, does this report mention problems with water damage? Just answer yes or no. And it goes yes, right? So then I've got water damage, yes, as a particular tag. Then I can do the same thing. I can say, does this report mention problems with the foundation? Just answer yes or no, yes. Are there problems with the roof? No, right? So I can just have a series of little simple questions where I say, just please answer yes or no. And then I can very easily get a language model to tag that information for me. And then, okay, good. So that's tagging. Um, so I've got two more use cases that I want to go over. One is evaluating and training people, which is just, like lots and everybody has this issue, right? So how do I um, understand what are the strengths and weaknesses of my employees and how do I get them to be better, right? So here's sales. So you've got a sales organization and you want to learn a predictive model. So maybe the data that goes as input to this is, what's the resume or the background of the individual? What are their KPIs, right? So what are the things that they're trying to do? What are the targets for things that they're trying to hit to indicate their performance? And what's their past performance? So, um, you're supposed to sell this much business in the first quarter and you got this much, for example. And then you can look at call transcripts. Model outputs could be things that are just important to you, whatever they are. So will they hit next quarter's sales quota? Where will they rank among salespeople in 6 months? Or what's the value of a specific KPI be next month? Now, that's useful just in itself because you can say, all right, well, I feel like this particular salesperson, they're going to miss next quarter sales quota by a lot. But then the question is, what do you do about it? And it turns out that many models are able to have some form of sort of explanation. Now, explaining what AI systems do can be a hard problem, especially if I've got a language model that's got 100 billion parameters or 100 billion numbers that control its behavior. How do I know what it's doing? But with certain kinds of models, you can actually sort of do things to probe, play what if. And so in this case, you might be able to say, of all the inputs for a salesperson, which are the most important? Is it their training? Is it the number of calls that they make? Do they have sales development representative support, for example? Now, if you know the ones that are important, then you can do things like say, well, the ones that are important and that I have control over, what would happen if I make changes to those things? So, would that salesperson hit their KPI if they increase the number of calls by 10%? Or suppose I hired an SDR to support them, would that let them hit their sales quota? And you can simply just sort of change the data that you pass into the model and say, oh, well, no SDR. I'm going to actually click SDR and say, yes, they've got an SDR. Does that change things materially? And if it does, then you can start making decisions about that. Oh, maybe I need to get them a little bit more training. I need to encourage them to increase the number of calls. If I invest in another SDR, they're going to hit their quota, which means I'm going to get this much profit, and that's going to be a good investment. So, lots and lots of ways that you can sort of think creatively about using the data that you've got to sort of figure out how are employees doing, how do you think they're going to perform, and then how might I help them perform better. And then I think this might be the last use case is writing proposals faster. So um, it's if you've written proposals, it's incredibly time consuming. So there might be lots of requests for proposals out there. You've got to sort through all those things. You've got to figure out which ones are relevant to you, which ones do you think you might have a good story for, and then ultimately write the proposals. And so very time consuming, challenging, labor intensive. And interestingly enough, large language models like ChatGPT can get you there faster. Now, I do think it's important to be cautious here because obviously the last thing that you want to do is to say, and you could do this, right? You could say, here's a call for proposals. Here's a bunch of documents that my company has generated in response to past calls. Please write a complete proposal for me. Now, that is not going to be very successful, but what LLMs can do, it's also dangerous, right? So like you don't know what the proposal's, like what's it going to say? It can promise all kinds of things that you can't deliver. But what LLMs can do is they can be sort of like very smart assistants or very diligent assistants that are aiding you to move the proposal process faster. And a couple of things that I've shown here is you could use it to extract information from an RFP. You can create a skeleton proposal, which I think is a great thing to do. Just, hey, like, just give me the structure, and I'm going to go in and sort of fill some of that stuff out, or write boilerplate, sorry, from company documents. So, if I need to put together text about past performance of the company in similar projects, or I need to provide information about the history of the company, or just statistics on the company, that kind of thing can be written. It should be verified, but LLMs can do a really good job of starting out. So here's an example. The Maryland Stadium Authority had a request for proposals. Again, I just found this on the internet randomly. It's construction management services, Baltimore Convention Center capital improvements, right? So there needs to be some work done on the Baltimore Convention Center. So what I did was I went to ChatGPT, and this is something very close to a transcript of what happened. Is I just clicked the paperclip icon here, and it said, okay, you want to upload a file. I just clicked on this RFP, uploaded the file, and I'm ready to talk to it. And so first thing I ask is, when are proposals due? Turns out that they were due May 10th, 2024 at 1 p.m. local time, right? So first check is like, okay, let's imagine this was a year ago. It's like, okay, I got time. I can actually submit this thing. So that's the first thing you might want to do. Then I said, how are proposals evaluated? Now, notice I added be brief here, because the first time I asked that question, it just gave me pages and pages of text. And so I really wanted to know what was going on. And it said, okay, there are sort of three things. There's technical criteria. Do you understand the project? What experience do you have? Do you have capacity to do it? How well written is the submission, right? And it also says technical proposals carry more weight. Then financial criteria, cost effectiveness, sort of standard. But then also it goes, oh, and also there's an oral presentation. So if you're shortlisted, you're going to have to go in and give a presentation, and that's going to influence the final rankings, right? So great to know. There's an oral presentation, technical, financial. Um, then I said, create a skeleton response to this RFP based on what they require. And it goes, okay, here's an outline. It aligns with the RFP requirements and ensures compliance with its format. And it gives me this thing. So there's volume one technical. I think there was also volume two cost proposal or something. So, but it's very specific. It says, oh, you need a title page that has this information on it. You need the executive summary, which has this information in it. There are required submissions. There's a bid proposal affidavit, a conflict of interest affidavit. You got to have a copy of the Maryland operating license, and it just sort of goes on and on and on, right? So again, very, very, very useful if what you're going to do is sort of look at this thing and go, okay, how much work is it going to be? I wouldn't totally trust this. I bet this is probably very accurate. You'd want to obviously go back and check, but this is a great way to get started. Now, the other thing that you can do, which is super interesting, is once you've had the LLM say, here is the outline of the proposal that I'd like to write, you can provide that as input. You could also have documents from your company, from past proposals, or your firm's qualifications. And you could say, hey, LLM, can you give me an initial draft of that thing? And again, modern LLMs will do a very, very good job of this. You have to do a little bit more work, because it's going to be hard or impossible to get ChatGPT to do this, because it's going to start to get mad if you try and upload tons and tons of documents. But there are systems out there that you can download. There's a thing called Anything LLM, which is an application you can download to your desktop, and you can just give it tons and tons of documents. And it uses an approach called retrieval augmented generation. It doesn't matter what that is, but basically it goes and looks through your documents, finds the most relevant information, and then uses it to generate a draft. So the barrier to entry here is actually quite low to doing things like that. So what are some considerations? So size of team and scale of effort. So is it one person? Is it you who are just trying to get a head start on this thing? I just want to look through this thing and see if I can understand what they're asking for, or are there going to be a bunch of people working on the proposal? Also, how many RFPs are you going to try and process, and what kind of documents will you use, right? And so if it's you working on one thing and then you're going to sort of do some work and hand it off to a team, then you could actually use ChatGPT, or you could use something like Anything LLM, or these other sort of standalone kind of desktop applications that can get you going. If, on the other hand, you're trying to sort through 100 RFPs and it's going to be big teams and it's going to be very complicated, very different kinds of documents, and you're typically going to need something that's more robust. There are lots of companies out there that will help you set up those kinds of systems. And so again, is it, should I use ChatGPT or a custom tool? If the interactions are ad hoc and you don't need to store the results in a database, then something like ChatGPT can do really well. If you want to have teams of people interacting with the RFP and related documents, that's harder, right? Or if you want us to use past proposals or bids of examples of like a corporate voice. So you can actually say, hey, language model, here's an example of some old proposals. Can you write this new proposal so that it sounds like our old ones? Those things get to be like a little bit more custom. So there's the spectrum between I can do really simple stuff by myself just on the web using a tool like ChatGPT, to I can download a thing that will allow me to sort of use larger number of documents and do a little bit more work, to I need something that's a bit more enterprise scale. But again, the good news is that at this stage of the game, there are lots and lots of products out there that can allow you to do that. So what are, just a few final thoughts, and then I'll stop and see if there are any questions. One is I'm hoping it's obvious that you don't have to work at a tech company. You don't have to be super computer savvy, or sort of understand the guts of LLMs to have use cases where AI can help significantly. So construction is an industry where, as you can see, I think lots of these things apply to construction. Some of these apply sort of more broadly. Um, and a lot of this you can do on your own. So it might be the case that it's just you sitting, for an hour and uploading a document to ChatGPT, and then kind of experimenting with the way that you ask questions until you get it to give you a response that seems like it's the thing you're looking for. Um, it's really useful. So using it as an aid for writing proposals is very straightforward. Outside experts can help you understand the art of the possible. So you probably have ideas about the way that the data that you've got inside your company can help you. Uh, but there's no substitute for people who really understand the technology to go, oh, have you thought about these other cases? The other thing that outside experts can help with is scoping projects to kind of fit your willingness to try out AI. So there are some companies that we talk to who are like, we need AI, right? Like our customers are asking us, how are you using AI in your products or in your processes? And we need to be able to say something real, not just to say we're using AI, but also because they believe that AI can help them do better, either sort of in internally facing systems or externally facing systems. And so it's hard if you haven't been using AI tools and techniques to understand sort of what projects are easier and what projects are harder, how successful they might be. And so typically what we do when we work on proofs of concepts is to try and work with people to say, okay, here are some things that you would like to do. We believe that, here's an array of from sort of easy, high probability of success to more speculative, it would take more work, but could potentially have higher impact. Where should you sit on that spectrum so that you can experiment a little bit, not spend a ton of money, and often establish credibility and show impact for the C-suite, for example, to say, yeah, okay, this looks like it's going to work. Let's do more of that. And then finally, just kind of this implementation stage. We've definitely worked with companies where we were advisors and they would say, we're going to work on this thing. We'd like you to do the work, but we'd like somebody in our company to like shadow, tag along, do some of the work so that we can kind of take it over. And then taking AI systems to production is just a very different kind of animal and poses lots of problems. And having companies that have experience doing that can be very important. So, okay, that's the end of the presentation. I appreciate you listening. I am happy to take questions at this point if there are any. Um,
Thanks so
and
much, Tim. We haven't seen any questions so far, but we'll wait here a minute or so to see if anyone has any questions. Feel free to populate them in the Q&A section of your Zoom webinar or even in the comment section. And that was a great presentation, Tim. Thanks so much for sharing all of the information. And it doesn't look like we have any questions coming in. So with that, we will sign off. As a reminder, we will be sending everyone a recording of this presentation as well as the slides to reference again or share with your colleagues. And I hope everyone has a good rest of their day. Any final words, Tim?
nope, that's good.
Okay.
Yeah, thanks for listening.
All right. Bye.